Now, there are a number of ways we can perform data management using a GIS. The first thing we are going to explore is working with features and also working with vector features. Vector features are essentially features that have a defined geographic coordinates and vertices that are composed of points, lines, and polygons, just like we can see in the map on the screen. And so for vector features, they are drawn by mathematical functions that render the various coordinates that form the various features on the map. So when I zoom into a vector feature, I can see that the shape of the vector is preserved regardless of the resolution and the scale of the map. Now, let us explore the various features that we have on the map. Now, in my project file, I have some shape files on my map. I can also locate this folder on my browser panel by going to the browser panel and expanding the shapefile. I brought in the places, roads, rivers, structures, and boundary files. I want to bring in some other files. So I'm going to bring in the geology polygons shapefile, and I'll select add layer to project. And I'm also going to um, work with the layers and the river layers. So first off, I can see that my geology is rendered as a polygon, which renders it above the other polygons. So this is currently blocking the other features in my map. So I'm going to move this down to the bottom for now. So okay, so that I can see the various polygons. Now I don't like the way my geology is currently being rendered. So to before I begin any other styling process for my geology, I'm going to right click and explore the attribute table. I can see I have a name column, a code column, and a class column. Now these have been coded by some values that are corresponding to the various information in the geology. Now to enable me see the geology clearer, I'm just going to uncheck some layers for now. Okay, so I've unchecked geology, I've unchecked the roads, rivers, and structures for now, so that I can see the geology better. Now I can see the outline of the formations for now. So to be able to get a better sense of what is happening in the attribute table, I'm going to perform what is called a join, so that I can append more information to my table to enable me to know what is happening in the various features. So I'm going to go back to my class folder. Okay, so under Nara I have a classes folder which contains information about the various classes of features in my geology table. I also have a class field in my rivers table as well. So I have classes for geology, classes for rivers, and also classes for my structures as well. Okay, so I want to style my rivers and geology based upon the various classes that are in my shapefile. And so first up, I'm going to explore the various classes in my um, geology. I have this open spreadsheet here which contains more information about the classes in my geology. So I'm just going to open that quickly so that I can explore what is there as well. I can also explore this table by going to my browser panel and expanding the classes table. Now I can also bring in the geology code table into my project as well. And so my geology has been brought in to my project. I'll move that to the bottom. So when the table opens, I'm just going to quickly rename that table for now. And if I open the attributes of that table, I'm going to see a code field. Okay, let me just drag this so that they are side by side. So I see that my table contains a description field that contains the formation names of these various geologic polygons, okay, coded by a class field which corresponds to the class field in the shapefile. So the shapefile contains geometry, while the table does not contain geometry but contains information that could be joined to the shapefile on the basis of a class field. So I'm going to perform what is called a join based upon the values in this class field over here. Now there are a number of other operations we can perform on a shapefile or on any geometry of a field. Uh, there are there are various types of geometry we can bring into our file. The first is known as a geo package. So if you right click any directory or folder and go to new, you can either create another directory under it, sort of like creating a folder in File Explorer, or you can create a geo package, which is essentially a single database file, or you can create a shape file or a file geodatabase. So those are the four main database structures that are available on the desktop for QGIS. Other databases would involve the use of something known as a database management system. So there are various examples of database management systems like Postgres, Specialized, SQL Server, Oracle, and other database management systems. In the GIS, we can also bring in data from other sources like web map services and also other web services like REST servers, web feature servers, and also other kinds of data. And so in our shapefile, in our project, we currently have shapefiles open. And so before we begin our project, I'm going to create something known as a geo package, which is essentially a file-based database management system. Database, essentially a file database that allows us to store all the features, okay, which we are currently storing in our shapefiles into one single file structure. So I'll go to my GPKG folder under my course folder, and I'll create a new geo package. And so a new geo package of GPKG is created. I can also explore the file in my project folder by going to Nara GPKG. And so this is essentially what the geo package looks like. It's a simple file-based structure that is used to store all our features, as opposed to the shapefile system that stores features in multiple files. So I can rename my geo package to allow me better manage it. I'm just going to call it Nara data for now. And so this is my geo package, and this is where I want to be storing the basic output from my project. And so under the layers panel, okay, we can also perform simple styling for our geology by going to the layers panel. And since we know our geology contains various categories, I can just give it a simple categorized styling using the name value and classify. And so we see we have different categories of information in the geologic formations. Now these different colors correspond to different geologic formations, but for now we can't actually understand this because we do not have detailed attribute information. So to do that, we're going to do what is called a join to allow us to create better understanding of what is in our file. Now this join is useful if you have data that has multiple information stored in other sheets. I want to bring those multiple information into your shape to improve the quality of the data that you are mapping. Okay, so it's good to be able to perform a join on that. So a join is essentially a spatial operation, and it is managed using the processing toolbox in QGIS. So to open the processing toolbox panel, I can either go to the processing menu and select toolbox, or click the processing toolbox icon here. That opens the processing toolbox on the left panel, just adjacent to the layer styling panel. All right, so I can go to vector features. Okay, I go to vector general and select join attributes by field value. So I'll double click this tool and it will open up this window where I can select options for my join. Okay, so the input layer into my join essentially is my geology layer, and I'm also going to select the field upon which the join will be happening, which is my class field. Now in the other field which contains the additional information for my join, that will be my geology table, and so the fields in the table I would select are the class field. Now you can see that the class field in my geology table would have to correspond to the class field in the geology shapefile for the join to be accurate. So what exactly will happen is that I would use a join type of one to many, which will create a join for every matching feature in the two tables. So wherever there is a feature here that has a class field that matches with what is in the table, then the join will happen for that. So what has essentially happened is a one-to-many join for both tables, where every feature is joined to as many as are matching, essentially creating a separate feature for every matching feature in the join. Okay, so for this operation, I'm going to use what is known as a temporary layer. QGIS creates temporary layers from analysis to allow us easily visualize the result of our analysis. And then when we are satisfied with the results, we can make those temporary layers permanent. And so I'm just going to click run to run the output from this analysis. And so right now I'm not seeing any errors, which means that my analysis ran successfully. So I'm just going to close this and I would see a new layer open. Now this icon here shows me that this is a temporary layer, and if I hover over it I can see that this says temporary scratch layer only. Contents will be discarded after closing this project. So I want to explore what the output of this looks like. So I'm just going to close every other table and right click the joined layer and say open attribute table. So I can see that I have the fields from the original layer, which is object ID, name, code, class, and the shape information. And I also have new fields appended to my layer, which is the class from the other table, the codes from the other table, and the descriptions from the other table. So what I can do is to organize this field so that I have a much more cleaner field arrangement. So I'm just going to come here and say organize columns, and I'll just uncheck some of the fields that I do not need for now. Okay, so I have a code field, I have a description field, and I have a class field. All right, now this layer is still temporary. Okay, so what I want to do is to make it permanent. So I'm just going to right click the layer and say make permanent. So what it will do is bring up a window for me to save the settings to export the layer into a file. So I'm going to export this into a geo package. There are also other data storage formats that we can use to export our files. We can export to a shape file, a file geodatabase, and other files. So I'll select geo package, and for my file name I will click the box here and browse to where I have my saved geo package. So I'll navigate to where my geo package is by going to the geo package folder and selecting my geo package. I'll give it a new name and say geology joined. Alright, so if I'm okay with those settings, I'll click OK. And now it will export the layer that has been joined into my geo package. And so if I go back to my browser and expand my geo package, I'll click refresh and expand it. Now I can see the layer that I just exported into my geo package. And in my layers panel, the layer now is now permanent. That's why I can no longer see that icon. So if I hover over this joint layer, I can see that the path here is pointing to my geology joint layer. So what I can do is to rename this layer so that I know that it is the geology joint layer. So I'll select rename layer. Okay, so I'm satisfied with this layer now. I can decide to remove this former layer. So to do that, I can right click and select remove layer, or come here and click the last icon here which says remove layer or group. So now I can perform another symbol styling based on the contents of this layer. I'll go to the styling panel, and with my geology joint selected in the list, I will now select the categorized styling, and I'll style that using the values in my description field. Now if I open my attribute table here, I can see that in my description field I have the formation names. Alright, now I want this to show up in the legend, so I will use that as the basis for my classification. So I'll classify, and now I can see in my legend here I have the various formations. So this is essentially how we can bring together information from multiple tables and use them in rendering and styling information in our GIS. Another thing we can also do is to style our rivers based upon information in another join, in another table. So I'm going to perform the same join on our rivers so that we can also style that based upon that information. If my table for rivers is not in the map, what I can do is to select it from my file explorer, and so I have this field 1 and field 2 showing up here, which essentially means that they are corresponding to the first and the second columns in my table. And so field 1, which is a numeric table, which is, as you can see, 1, 2, 3 over here, essentially corresponds to the first column here, and field 2 essentially corresponds to the second column here. So another thing I can do is to rename or add a new table, a column header before I use that. So I can say this is the class, and I can say this is the type. And now I can see my column headers are now showing up here. So I'll perform the join, which is a one-to-many join based upon my class fields, and I'll store that to a temporary layer. I can also store that to a file if I do not want to use a temporary layer. So when my analysis runs, I have another joined layer, okay, which has been created. So I'll uncheck the first layer, and if I open the attribute table for the joined layer, I will see that I now have a type field corresponding to the various categories of streams and rivers that I have, which I can use to perform more extended styling of my streams. Okay, so I'm just going to briefly organize this. All right, so in the layer styling panel, I can let me rename this first. I'm going to rename this to rivers joined. Okay, so I'll make this permanent by saving this in our geo package. So I can explore my geo package to see that it is now there. I'll hit refresh. And now I can see my geology and my rivers. So I can give my rivers a categorized symbol based upon the values in the type column, type 2 column. And so when I click classify, I can now see the various classes of rivers. Now I can give all my rivers a particular style. I can come and change. So when I click each one, I can hold down the shift key and click others. Alright, or I can click and drag and select everything. Right click, change color. Alright, I can give it a particular color like blue. Okay, now for major rivers, I want them to be thicker than the others, so I'll double click the symbol. Alright, and for the simple line, I can increase it a little. So now you can see the major rivers are highlighted with a thicker symbol. Now for minor rivers, I'll just bring them down, bring rivers up. I'll increase rivers slightly above the others, but not more than the major rivers. And then for streams, I'll make them a little thinner. Okay, and then the others, I'll leave them the way they are. So if I'm happy with this, okay, I can save, and now you can see that I have been able to style my rivers based upon the values from a joined operation. Okay, so that's how we can apply joins to features in GIS. Now, one more thing we can explore is how to perform selections based upon the values in a, a feature or a vector feature or in an attribute table. So I want to join a table to our places layer, which contains population attributes. So I have this sample population table from I created, which contains sample information. I'm just going to add it to the project. Now this contains sample population information for these towns which I just created, and so we can use this information to perform simple queries and simple selections on our project. So what are selections? Selections are essentially how we can perform or query the information in our database by using SQL queries. So in our database, we have a series of rows and columns, and we have a basic column known as the ID column, which appends numerical serial numbers to every record of a shape. So every shape contains a geometry column, which can either be point, line, or polygon. Now these are the basic types, but there are other extended geometric types, but these are the basic geometric types which are also in the geometry field. And so every row contains this ID column, which is a numerical value that is given once we create a feature for tracking the number of features in the database. And so when we perform a join, we're essentially using one value in a field which contains a unique ID that is unique to both tables. So if this is table 1 and this is table 2, our join is going to be performed based upon the fact that the tables and the values in these fields correspond to one another. And so when we join, everything in column A is joined to what is in column A, and everything in column B is joined to what is in column B. Alright, so when we perform a selection, what we are essentially doing is asking the GIS to bring up a particular record based upon the features, okay, or based upon a set of criteria which we define using a programming language known as structured query language. It's a query language that allows us to query information in a database or in a table, just like our shape table, to extract a number of features that meet a certain criteria. And so in our places table, we currently have a number of features which have name attributes. And so before we perform our query, we're going to use our name field as the join parameter to allow us to join features from our population table. So I'm just going to quickly perform a join with the population table to bring that into our places table. And so I'll just make that permanent quickly. And so if I explore the places table, I will see that I now have this population information attached to my places table. Alright, so what I can do is to perform selections on my map. So I can select using a number of features and a number of selection tools. So selection is done using the selection toolbar, which is this toolbar right here. I can also toggle on the selection toolbar from the toolbars menu here. And so when I click this, it says select features by area or single click. So I can select any feature from the layers. Okay, if I click this point, I essentially select that point. Okay, and in my attribute table, I can see that that point is currently highlighted. Okay, if I click the list, numerical list here, I can switch selections around. Okay, I can also zoom to that my map to the particular selection that I'm interested in. Okay, Now if I click and drag, I can select all features within that selection panel, within the box that I create, as you can see, and all those features are selected in my attribute table. All right. So you observe that I'm not selecting features in any other layer, because the current layer that's being selected is the one I highlighted. So if I want to select layers in geology, for instance, I'll have to click geology, and now I can select layers in the geology field. So the same thing applies for other layers in the map. And so if I have something selected, I can deselect it by coming here where I have this icon that says deselect features. Okay, so I can select all selected features, whether from the active layer or from all layers. Okay, so one more thing I can do is to select features by location. Okay, which can allow me select features that occupy a particular location within my map. All right, so what I want to do to my populations table is to filter it using information in my attribute table, which is essentially this population field. So I'll select places which I have joined, and I will perform what is called a filter. Now a filter allows us to filter information in a table based upon values and attributes. So take for instance, I want to filter values in my population field that are greater than 5,000. Okay, so what I can do is to create a filter and apply a SQL query. So what I can say is to select star from the name of the table, which is places joined, okay, where the name of my value of interest, so I'll double click population and I'll say greater than 5,000. So I can test this to know if my query works, and it says the query works and your clause returns 6 rows. So if I want to see a sample of the values that I've returned, I will click sample so I can see all the sample values that are greater than 5,000 here. If I want to see all of them, I'll click all. Okay, for now I only have 6 values. So if I like the outcome of my filter, I'll click OK. I can also save my query so that I can reuse it later by clicking save. And so QGIS saves that query into something known as a QQF file. So I can go to my project folder and store that in this query file called the QQF file. So I have this query I made, okay, which I made earlier. I use that to save that query. So I can click OK, and now you can see my information in my attribute table has been reduced to only point layers that fulfill that query, right? All right, so and now in my layers panel, I can see this funnel icon telling me that this particular layer has been filtered, okay, and it's showing me the query for the filter, which essentially means that there are more values in this layer, and what is showing is only a filter from the values. So if I like my filter, I can also export it so that I have a layer containing only the values from the filter. So I can right click and say export, save features as. Okay, now in my geo package, I can say this is the one that has been filtered. Okay, so if I open the attribute table for this, You can see this only contains values from the filter, and there is no filter icon here as well, showing that this is only the values that have been exported from the filter. Okay, so with this now, we now have a basic understanding of how selections work and how we can manipulate features in our map. We've also talked about working with database files and also how to export information from our database, okay, using filters, using SQL queries, and also how we can manipulate information from our map to allow us to understand and explore the features in our map more easily. We also looked at how to join layers and how to work with geo packages for exporting information from our map. In the next tutorial, we're going to work with raster data. We're going to explore how we can visualize and symbolize raster information using a GIS from our database.